Hello everyone, welcome to this session. We are discussing about the extractions of the metals. Today, let's discuss the extraction of the sodium. So far in our previous video, we discussed the extraction of moderately reactive metals. We saw the various steps in extraction of these kinds of metals. So today, let's discuss the extraction of sodium. Uh, the extraction of sodium from its ore. Now, we have to know that the alkyl metals are the strong reducing agents, and they can be extracted by chemical reduction of the oxides or other compounds. So they cannot be extracted by the reduction of the oxides or other compounds. Now, the only possible method or way of the extraction is simply by the electrolysis of their fused chlorides. So let's see the sodium, that is the one that is extracted by this, the electrolysis of the fused sodium chloride. So the sodium is extracted industrially by the electrolysis of either the fused sodium hydroxide, that is the Casson's process, or the fused sodium chloride, that is the Downs process, in which sodium chloride is electrolyzed in the molten condition. Now, in this case, let's see the sodium chloride by the traces of sodium chloride by the Downs process. So in this case, the fused sodium chloride is the one that is used for the electrolysis of this. Now, and because the melting point of sodium chloride is high, that is about 800 degrees, the calcium chloride is the one that is added to lower the melting point to about 600 degrees, and that economizes on the electrical power. Now, the composition of the electrolyte is 40% sodium chloride and 60% calcium chloride. Now, the down cell, as you can see in the figure coming after this slide, used for the extraction of sodium consists of an iron box, through the bottom of which lies a circular carbon anode. Now, as you can see, this one is our Downs process, and this is how it looks like. So the explanations which you are going to see will be based on this Downs process, and this is how it looks like. Here, this where the fused sodium chloride and the calcium chloride is added, and here is where the chlorine will be removed, and here the storage tank for the sodium after the process of the electrolysis. Here there's carbon anode. There's also iron gauze diaphragm, and the iron cathode. There's molten sodium that is will be around here, and there's still food, that is this one. So this is just the structure of the Downs process. So the explanations will be upon this Downs process. So a ring-shaped iron cathode, it surrounds this carbon anode, and the cathode is enclosed in iron gauze diaphragm, which also separates the two electrodes. Now, at 600 degrees, the sodium and the chloride produced would react violently if allowed to come in contact, whereby a diaphragm around the anode, which keeps the two products apart, prevents this kind of situation. Now, during the electrolysis, the chlorine is liberated at the anode and escapes via the hood, as we've seen in the diagram. So sodium is done that is liberated at the cathode, collects in the inverted through placed over the cathode, rises up the pipe, and overflows into the storage tank from which it is tapped off through the iron vessel. Now the sodium metal is collected upwards in the down cell because of its low density, which makes it float over the mixture. So that's the reason why it's collected upwards in the downward cell. Because it's low density, it makes it to float over easily over the mixture. Now, the sodium metal from the down cell, it contains some calcium, which is also formed through electrolysis, and the calcium crystallizes when the mixture cools, and the relatively pure sodium metal is obtained. So this is a down cell. As we've seen the explanations, I hope it's clear to everyone. So The fused sodium chloride produces the sodium ion and the chlorine ions, whereby the sodium ion moves to the cathode and the chlorine ion moves to the anode. So the reaction takes place at the electrodes as follows. So here at the cathode, the sodium ions will melt to this sodium, and at the anode, the chlorine ions will melt to this chlorine gas. So in the cathode, there's a reduction process whereby at the anode there's an oxidation process. Now the chlorine gas is therefore formed at the anode, while the sodium metal is produced at the cathode. As you can see here, simply how the reaction it took place. So this will be the result: sodium as solid and the chlorine gas will be liberated. Now the chlorine is the one that is a variable byproduct of the decomposition process. I hope it's clear, guys. Thank you for listening. I will discuss the electrolysis process of the extraction of the sodium. Simply, we've seen the electrolysis of the sodium chloride to obtain the sodium as the main metal that is required. Thank you.